So let's go through an example of cosine with a good set of weights. Right? There's our equation for cosine. We have the QW and the DW, and the way we set them is just using tf-idf weights that we talked about in the previous lecture. So QW, that's the weight of the word W in the vector Q. So we have the number of times that W occurred in Q, squashed and normalized for the length of Q, multiplied by the IDF of the word W. So that whole thing is the weight of the word W in Q. This whole thing is the weight of the word W in vector D. And now we plug those quantities into the cosine, and we can measure similarity between Q and D. Right? Very, very straightforward. So where do you use this? Yes?
The items coordinates space in Q and D are computed differently for Q and different for D.
The IDF.
Yeah.
So the question is, I'm sorry?
Or are the same.
Okay, so the question is, the IDF, are they computed the same or differently for Q and for D? So if you look at the IDF, there is no Q or D here. IDF is independent of the vector that you're applying it to.
No, I mean that you need some corpus to do statistics on. And you have the set of documents and set of queries, right? And
oh, I see. Okay, all right, I misunderstood the question. So what you're asking is, if you have documents and queries and they're separate entities, do you compute different IDFs for the queries and the documents? No. You do this. An IDF is supposed to be a global thing. It is a measure of how useful a word is in the vocabulary of the language that you're dealing with. Yeah. Yeah, you pretty much use everything for computing IDFs. You could imagine doing it separately, but I can see no reason why that would work better than putting them all together. Yes.
So when you have like a few queries and you have a lot of documents in your index,
yes.
So typically you don't include query IDFs. Like you don't include the number of times that the word appears in the query in the IDF.
Okay, so the question is, if you have a lot of queries at once, do you use the queries for computing the IDFs in a normal... so it really depends on what your task is. If your task is a retrieval task, then typically no, you don't. And the reason why is a classic definition of a retrieval task is you don't have a bunch of queries at once. You have a collection of documents, you can compute some statistics and build an index from that set of documents, and then users come in and they enter whatever queries they have live. Right? You don't actually get a chance to collect all the queries for 20 years, do the ranking, and then send them the results. So usually you do it just on the document side. You could imagine a situation where you have a static set of queries, and in that case you could consider including it. But usually the IDF just comes from a single set of documents. That's where you compute the document frequencies. Okay. So you use it for, as I said, you use it for document-to-document comparison purposes. You compare two news stories, two essays, something else. We already talked about some basic properties. The higher this quantity, the more similar the two pieces of text are. The lowest possible value you can get is 0. You get a 0 only if the query and the document are completely perpendicular in the vector space, and what that means is no words in common. So all of the words, none of the query words occur in the document, and vice versa. So that's how you get a 0. You get a 1 if and only if they are pointing in the same direction. If the vectors are parallel, and one is just longer than another. And what that means is they have exactly the same words in exactly the same proportions. So not frequencies, right? The document could be 10 times as long as the query. But if you get a 1, it means that somebody took the query and replicated it 10 times to form a document. That's the only way you get a 1 for a cosine. Keep in mind, we do discard word order, so it's replicated 10 times, but it could have been reordered. Okay, the cosine, as opposed to a weighted sum, is a symmetric measure. So it doesn't, there is no notion of query and document here. You're just looking at the angle between the two vectors. And this is attractive when you have many-to-many matching problems. So the example of this is plagiarism detection. You ask 100 students to write essays, and then you're looking for cases where one student may have copied another student's essay. That's a many-to-many matching task because you basically compare one student against all the other students in your data set. And in that case, you want a symmetric measure. Okay, couple of notes. So sometimes you use a squashing function. Sometimes it's better not to use a squashing function. Both are used in practice. And the IDF sometimes is replaced with the square root of the IDF. Can anyone guess why? So that it doesn't care if you get 0. No, not quite. So the reason you replace it with a square root is if you look at the dot product, if you multiply this guy by this guy, the weights, you get the IDF twice. So you effectively get a square of the IDF. And that doesn't behave quite like the original IDF. So to cancel that out, you take the square root when you apply the weights. And then when you multiply a square root of IDF by another square root of IDF, you just get your IDF back.